Okay, I'd like to actually do one more thing here. I think I'm still here and I've added another test the model on another region because this is how I was going to do the check. And then I realized, well, we're going to need to adjust the model a little bit more to get a good result here. So here we go. The idea is that what I wanted to do for the check is to have you see, we've designed this model to calculate the land surface temperature anomalies for every pixel in the image for Baltimore. And now let's see if we can just apply this elsewhere by changing the point. So I'm going to go and edit this and hit the trash can and say, yep, I'm pretty sure I want to delete that. Because remember, the geometry is what defined our region. And this is one of the reasons I like using points rather than properties, because it makes it pretty easy to just focus on another place. So this is what filtered that urban area. So I'm going to kind of cruise over to Houston. Um, and there it is. And I'm going to go zooming in and just basically somewhere around the S or the U, I'm going to grab a new point and kind of click it in there. And so I should now have a new geometry point, single point, somewhere on the label of Houston. And if I click run, and it'll take a little bit, and it'll think about it because it's got to load the modules, kind of go through all of this. Houston's probably bigger urban area than Baltimore, so it's a larger task we're asking it to do, but it should start working on it. And eventually, what we should get, hopefully, if this works right, is we should get a red and blue map for the urban area of Houston. And that looks good in the sense that it's a red and blue map of Houston. But the problem is that there's this pattern of blotchiness, that these kind of streaks of blotch, for lack of a better phrase, that kind of cruise around here that make me wonder if those are clouds, right? Especially because they seem like they're covering up um, places that might be a little warmer than they are. Um, that to me looks like cloud cover. And I know that we filtered this so that we were only going to grab images that had 10% or less of the scene covered with clouds. But what if 10% of the scene was just some clouds right in here and right over there? They're gonna come out as cooler because you're not going to get the ground surface temperature. You're going to get the light reflecting off the clouds. Okay, so let's see if we can do some surgery here. And I think Sophia's script has a cloud mask in it, but let's just double check and go to the primer here, and we're working with Landsat 8. So let's grab Landsat at 8 and let's grab this cloud mask. So I'm going to kind of grab everything from that curly bracket to the top here, copy it, come over here, and before we apply our additional filters, let's get ourselves that tool. So now we should be able to call that cloud mask L8 and say, all right, we're going to take things that are just less than 10%, but then once we get the relatively cloud-free images, let's map this cloud mask over each image to scrub out any pixels that are cloudy. Does that work? And so now I can say run, and what do we get? So what we should get is there's Houston, and we're going to get eventually a new image drawn. And in the meantime, I'm just going to hide that blue push pin, and here it comes. And so I think we've cleaned it up a little bit, but I think what we may wind up with is some holes. Um, so we do have some holes here. I can't remember if we had them previously, but does it look like we've cleaned that up a little bit? So we are kind of seeing through. And another thing that we can do is say, well, now that we're kind of removing, it looks like we still might have some artifacts kind of cruising through. It's tough with this larger area. But maybe what we should do is bump up this may be counterintuitive, but what if we said, hey, we'll allow maybe 15% cloud cover, but then have this cloud mask that tries to scrub out those cloudy pixels. So maybe that gets us a few more images that might have eyes on the ground. Does that make sense? Like we can be less conservative with this because this is just going to throw out an entire scene based on how much of it is covered by clouds, and that but this is going to just try to keep whatever is good in a scene if it's not covered by a cloud. Is that fair? Like this is a more drastic way. And so that's starting to kind of clean up this image. I think it does. And so I think we've just improved our model in the sense that we've made it more transferable to be able to investigate other areas simply by adding this cloud mask. Is that all right? And I think I'm gonna just stop it here and just say, okay, hopefully you guys have followed along. You've bumped up the cloud cover to 15 and you're now mapping this cloud mask over it. And we have a model that is maybe a little bit better suited to go after different areas. And if we quickly check to our area of interest, you can see that these holes actually came through because they're not part of the urban area. But I think we've gotten rid of some of the cloud errors that our original model that we designed for Baltimore have. So this is a stronger model, and it also just goes to show how it's kind of helpful to build a model at one place and then check to see if it applies to another place, to see how much just how transferable the work that you're doing is. All right, so that's going to be saved, and I think now I really will give you a checkup, but it'll probably be for Houston.